In today's lesson, we're going to be examining the introductory lesson to the gas law unit. We're going to be looking at properties of gases, including pressure, volume, temperature, and the number of moles of gas present. We will be using the PhET simulation software, and this is the basics of gas laws. First thing I want you to observe is that we have a container that has gas particles in it. You'll notice that the gas particles are moving around rapidly and randomly, and they kind of go in straight lines until they collide into something. Either they'll bounce into another gas particle or possibly the walls of their container. We have some observable characteristics here. We can look at the pressure of a gas listed here in the unit of atmospheres. We can look at the temperature of the gas listed here in Kelvin. And so we can do several things to manipulate the gas inside this sealed container. We can do stuff like we can add more gas with this pump. We can actually remove gas by opening the lid. We can change the temperature by either putting heat, so we can put some flames on, or we can put some ice cubes on it and lower the temperature. We can actually change the size of this vessel. We can make it bigger or smaller by expanding the wall. The first question I want to pose to you, what do you think pressure is? What do you think a definition for pressure would be? I'll give you a moment to think about that and respond. Okay, well, pressure is defined as a force per unit area. Okay, so essentially what that is as these gas particles are colliding with their container walls, they're exerting a force on it. And so that's really what pressure is. It's these gas particles pushing out on whatever they're contained in. Okay, so we're going to do some different manipulations here, and we're going to see how it affects both things like pressure and temperature of the gas. And so maybe the first thing we're going to do, maybe I'm going to put some heat on it. So I'm going to add some heat, add some energy, some thermal energy to this container. First, what do you think is going to happen to the particles? Do you think that the particles will speed up? Perhaps will they slow down? Or do you think they'll kind of move just like they're moving now? Give you a moment to think, and then we're going to increase the heat on them. Okay, so here as we're adding heat, you can notice the temperature is going up, and you can observe those particles are moving around much, much faster. And then you'll also notice as we did this, the pressure increased. So it looks like with the temperature increased, pressure increases. Okay, so then vice versa, I guess let's take some of the heat away. Let's cool them down. Let's put some ice cubes and make some observations. Okay, so you notice the gas particles are slowing down. The temperature is going down. The pressure is going down. They're not colliding as frequently with the container walls. They have less pressure. Okay, so that's some of the things we can do to kind of manipulate, so just using temperature alone. Okay, let's see what happens if we squeeze the gas. So the volume, let's say this is a flexible container. It's not like a rigid box. It's something where we can either make it bigger or smaller. So if I take this box and I start squeezing it, what do you suppose is going to happen to the particles? Give you one moment. Let's squeeze this and make it a little bit smaller. And then all of a sudden, hey, the pressure's jumping up. Okay, so as you get there's a smaller space, there's less space between the gas particles. They don't have to travel as far to contact the walls. Volume gets smaller, pressure goes up. Vice versa, let's take this and expand the container and make the container bigger. Okay, now those gas particles are all spread apart. Notice it takes them longer to travel to collide with the walls of the container, so the pressure drops. Okay, what do you suppose happens if I add more gas particles to this? Give you a moment to think here. I'm going to take this pump and I'm going to introduce more particles to it. So here we're adding some more gas particles. Pump, pump, pump. And More particles, pressure increased. They're colliding more frequently. There's more things there. Let's say I let a few of these things escape. If I open this top, what do you think's going to happen? So I open the top, you can see some of these particles escaping. Okay, notice pressure's going down. So's the temperature. Okay, so stop and think here just for a moment. What is a good definition of temperature? So we've talked about temperature, but what is temperature really measuring? I'll give you a moment. Okay, temperature is actually a measure of the average kinetic energy of particles, so the energy of these things moving. So if I open this container up, you'll notice that some of these gas particles are escaping. Okay, as they're escaping, they're taking their energy with them. And so the energy of the system, the particles left behind, is less. Less energy left behind, less temperature. Okay, seal that up. And pressure's gone way down, temperature's gone way down. And let's add some more particles to it. We had a bunch escape. And then let's add some thermal energy, get them speeding up again. Slow going, you can see them, and they're starting. The energy's kind of starting to spread throughout the particles. There they go. Let's see, what haven't we manipulated? Let's see what happens if we continue just to add particles. I continue, you notice the pressure is going up and up and up and up and up. Oops, looks like it stopped. Oh, I'm out of particles, that's why. Well, it doesn't let me add any more. Let's try some light particles. Ooh, we got some smaller ones in there. Ooh, blew the lid off. Notice pressure dropping rapidly, temperature dropping. Let's seal them in. Okay. Well, hopefully with this lesson, you've kind of recognized the interrelationship between pressure, volume, temperature, and number of particles. I'll ask you a few questions, and thanks for participating.